Light gives a stopping potential of 6.0 volts. When the wavelength is made 4 times and the intensity is halved, the stopping potential becomes 0.6 volts. We need the first wavelength and the work function. Let us solve step by step. Use Einstein photoelectric equation in electron-volt form. The stopping potential gives the maximum kinetic energy in electron volts. Intensity changes the number of electrons, not the stopping potential. Let the photon energy of the first source be x. Since the second wavelength is 4 times larger, its photon energy becomes 1/4 of x. Subtract the two equations to eliminate the work function. This gives x equal to 7.2 electron volts. Now use the given value of Hc by E dividing by 7.2 gives the first wavelength. Also, x is symmetric because opposite of diagonal entries are equal and its trace is 18. Finally, the work function is photon energy minus the stopping potential energy for the first source. 30I is singular, not invertible. So option D is false. The correct statements are A, B, and C. For more clear step-by-step 7 meter, and the work function is 1.20 electron.